Good morning. My name is Eric Osterweil, and I'm a graduate student at UCLA in the Internet Research Lab. So today I'll be talking about a system that we've developed called BGP Origins, and it's an application of a concept that we call the public space. This work is in collaboration with Professor Dan Massey at Colorado State University and Professor Bichuan Zhang at University of Arizona as well. So our system is motivated by observing sort of a well-known problem at this point, which is that definitively being able to map origins, prefixes to origins that are allowed to announce them is not necessarily straightforward in sort of real time on demand. And that's mostly because it can, depending on how it's done, fly in the face of sort of operational autonomy, basically being able to suballocate, et cetera, and so forth. Being overlaid with a sort of a rigid framework is not necessarily straightforward. And so our system is motivated by basically the precept or the observation that maybe if we use sort of real life, real world trust relationships, maybe this situation becomes a little bit easier. So there are a number of approaches that exist to deal with this in various ways today. And so my ASN is a well-known example. Basically based on sort of like a registry mapping, origins can, or sort of origin owners can be notified when there's an issue, something like a prefix hijack, et cetera. And again, but this is based on essentially registry information that is registered, that then potentially can become stale. A similar approach that takes kind of a different angle is FAS, the prefix hijack alert system. And while that also intends to notify people, not necessarily just the owners of a hijack, it makes its conclusions or notifications based strictly on observations. So from monitoring points around the world, observing what the origin sets are, and then notifying anyone who signed up if something has changed. So these are great. There's no problem with. I don't think there's any issue with these approaches by themselves. But what we're motivated by, in part, also, is that third parties, people that aren't necessarily prefix owners, or people that have queries randomly at any given moment, not ahead of time that they can sign up for, should have a way to say, I want to look up an origin mapping. I see something suspicious, and I'd like to know what the status is. So there's a lot of work in SIDR CIDR that we think is great, and we have no bones with that at all. What we recognize is that it's underway, and it seems like a very good idea, but it's not here today. And until it rolls, I think it might be fair to say, does it have the sufficient granularity for operational use? Do people still have the needed autonomy to suballocate, et cetera? So it's more a question. It's not really a statement. So now I'll talk a little bit about the approach we propose. Again, BGP Origins is an application of a concept that we call the public space. And in this context, essentially what we're saying is that anyone can make an attestation, can claim that they think a mapping between a prefix and an origin is okay. So they essentially proffer up their informed opinion. And the system itself, BGP Origins, doesn't in any way try and verify that an origin mapping is a good one. It's not the system's job to arbitrate, to be the final answer. It essentially just lets people sort of put in their opinions, and it actually just sort of represents what's kind of the current consensus or thoughts about origin mappings. I'll get into a lot more of the details soon. So our main goal is really to provide more or less a complementary lookup system service. So we want to design something that is automatable. So I mean, like, it's great if you can call up your buddy at an operations center somewhere and say, hey, I'm seeing this weird announcement. Do you think this is okay? But what we'd really like to do, and what we've tried to do with Origins, is provide an automated framework so that you can basically build a script that can sort of do a certain amount of arbitration automatically, and as sort of a look-aside mechanism, basically use information that's out there to see what to do when something suspicious happens. And I'll get into some more of the details, but these user attestations are cryptographically signed. So if, for example, I say that there's a mapping, no one may care what I think, but I certainly can't later say, no, I never said that, because we'll apply a cryptographic signature. So at a high level, BGP Origins runs off of two different types of data streams. One is observed data that sort of culled from around the world, which is basically monitored traffic, update streams, et cetera. And the other type of data comes from users. as I've sort of been alluding to, users can make attestations, they can sort of claim prefix origin mapping, etc. So these are two, fairly different types of data sets, but we roll them in together because we feel they're both important. So BGP origins is sort of a rigorous framework, and what that basically means is that it's something that's geared towards being automated. So if I typed a nice letter and I put it in BGP origins, someone could download it and read it, and they'd understand it. But what we've done is tried to make it so that you can easily sort of write a script to parse things out, et cetera, and so forth. The whole system is designed, again, to be kind of a framework to be automated on top of. And so our input to the system is, as I mentioned earlier, cryptographically signed. So our observed data actually comes from FAS, which I mentioned earlier. So we get a feed from them, and we know that the data is integral. And then the user attestations are actually signed by their PGP keys. So in that sense, we can do sort of simple verification, and we can do online validation, et cetera. And the interface for our system is designed to be what we call quick but not dirty. So in order to make this very easy to use, we've just basically plugged the DNS. We basically use the DNS protocol. And what that means is that people can sort of query us from the command line, or you can write a script with NetDNS or any number of other common tool sets to pull data from our system, and actually also to upload data to our system as well. So clients basically can, as I said earlier, can verify the individual data, but now they can also verify that the data comes from us. So we're not saying that we're the most trustworthy organization in the world. You can certainly verify the signatures yourself, but we'll verify that the data did come from us, and then you can individually check it. So what BGP Origins does not do is, again, it doesn't guarantee that the data it serves you is in some grand scheme true. We don't provide the ultimate authority on what a valid mapping between a prefix and an origin is, and it's not even close to what our system's trying to do. We basically provide a framework for you to get information that's observed and posted by others. In fact, we don't even guarantee that the data won't be conflictatory. So, for example, I may attest to an origin in a prefix binding, and somebody else might attest to a completely different origin. And when you ask about a prefix, we'll get both of these back. And it's really left up to the endpoint to use the information and the trust relationships that you may have a priori to decide, I don't know who Eric is, so that's not important to me. And all we'll really do is tell you that the data did come from us. We'll provide you the origin authenticity that BGP Origin served this to you. It wasn't a man in the middle of the time. So let me try and maybe sort of pull this together and clear it up with an example. So I'll start off with what probably everyone here knows. It's just a simple discussion about how things might work with BGP. So consider a timeline where at the bottom of the screen you can see at T0, origin N has announced a prefix that's non-routable. And depending on people's position in the internet, they'll hear that. I'm sorry, people will hear that. But let's suppose at T1, a separate origin announces the same prefix. So now, depending on people's position in the internet, some of them will hear one, some of them will hear other, some people will hear both. Their routers will ultimately probably just choose a path, but nominally some routers will hear both and some won't. So Alice on top right will at T2, a later point, say, okay, well, I see N, so that's the mapping. And Bob down in the lower left-hand corner may see both. And so if he's inspecting his traffic, he might very well sort of wonder why all of a sudden there are two. That could be valid, could not be valid. But at this point, Bob doesn't really know anything. So now, what BGP Origins allows is Bob to basically do some level of investigation. So let's revise the situation a little bit. Let's suppose that Alice, for whatever reason, has previously decided that N should always be the origin for this prefix. Now, maybe Alice has some inside information, or maybe Alice just maintains a list of well-known something or another's, sort of like, like a Bogon list. People maintain lists. So suppose Alice is one of those people. Now, when Bob, who may very well be friends with Alice, queries BGP Origins based on this sort of interesting, strange behavior, what he'll see is that Origins sees in the baseline data M and M are both origins, which he probably already knows because he asked the question. But he'll also see that his buddy Alice has vouched for or attested to the fact that N should be the origin for this prefix. So at this point, this really is still Bob's decision. Origins hasn't told Bob what to do. But now Bob has some real useful information in a very simple way from anywhere on the internet, on demand, whenever he wants it. So given the question, which origin is the right one, opinions really do vary. not everyone's going to trust Alice. And people will have different people that they trust. And multiple people may make the same attestation, and as I said earlier, some people may provide different information, conflictory. So it's really up to the endpoint to decide whose opinion matters, whose opinion really should carry sway. And this is something that can be automated with the concept of trust anchors. I come up with a set of keys ahead of time that I trust, and those are the ones I want to look for. So when you query BGP origins, you'll get back, again, these two types of information. You'll get back what's observed around, which was the MN tuple, and you'll also get back the attestations of people that you trust. In this case, it was Alice. So how does this translate to any kind of operational use? So this is sort of what we envision. Operations, maybe like automated processes even, can basically start to use these trust anchors, maybe like files of key IDs or something like that, that they'll query for. And they'll use to say, given a funny situation, I'll arbitrate in the following way. These keys hold sway. Let me see what their opinions are. But ultimately, it's not up to BGP origins. And everyone at the endpoint makes their own decision. Different operations groups can do completely different things based on completely different sets of data, not because they'll only see some, but because they only care about certain views. And again, as the picture sort of tried to describe, this is really kind of a look-aside system. It's not like we proposed to interpose between, accepting, update announcements at a router level and sort of discard things and so on and so forth. This is mostly designed for forensics or, look-aside validation. So things can still, we're not proposing any changes to BGP or anything like that. So now I'll talk a little bit about our first type of data, the observed data as opposed to the user data, which I'll talk about later. So our observed data comes from viewing data from multiple peering points around the internet. And we actually get this by just simply taking a feed in from FAS. And FAS actually was the subject of an earlier talk. I believe it was NANOG 38. And so I have the link here. If people are unfamiliar with it, by all means, check it out. But basically what FAS does is it pulls feeds from route views, and it processes them. And among other things, it looks for origin changes. It says this origin's been added to this prefix, this origin's been removed from this prefix. And so since it's already done the work of getting data from all around the world and coming up with a simple, digested sort of exactly what we want kind of data stream, it frees BGP origins from having to reinvent the wheel again. And in fact, from talking with the FAS people, I'm under the impression that they're working towards integration with RIS, the RIPE NCC data set, which for us is great because it means we get a richer data set for free. So again, so what we do with this data set is rather than give you all the noise of announce, withdraw, we actually try and do a certain amount of smoothing. And this is actually where I really want to make it very clear that the system is an early development system, and it is very strongly encouraged, or I'm sorry, it's very open to comment. In fact, we would love to get feedback about this. So what I'm going to go into now is essentially what we think might be useful, our idea of a first step, and what we hope is that when you query the system, that gives you back a useful data set that maybe by itself doesn't tell you the absolute truth, because again, it's not going to be easy to come up with the absolute truth, but maybe just filters out some obvious noise. And so again, I'm very interested in hearing your feedback. If you think this is way off in the weeds, I'd love to hear it. If you think this could be tweaked, or if you think that something else would be better, comments are great. Grab me afterwards, whatever you want. But this whole system is basically, it's a work in progress, and it's designed to be useful to this audience. So I would love to get feedback at any point. That being said, this is our initial first step. So we kind of take this data set from FAS, which is nominally kind of noisy, announce withdrawals, and we just try and run a low-pass filter on it. Just filter out things that seem like they might be pretty clearly not interesting. Like if you're actually asking a question, what should the real origin be? Are there certain things we can just sort of kick out? So we use a moving average. It's an exponentially weighted moving average. For those interested, this is just a very simple formulation of it. But essentially what it does is over time, it keeps an average for each prefix origin binding. And it says, and what it's trying to do is it's trying to squelch transient withdrawals, or transient announcement withdrawals. So something that shows up and goes away, we presume that this is not going to be the kind of data you want to see when you ask about an origin. So this average will squelch that. It'll also basically reward or upgrade consistency. Origins that constantly announce the same prefix will have a high average and they'll be presented. And we've geared it to sort of accept newcomers for, emergency situations where a new AS will announce a prefix that we've never seen before. It'll start off better than these sort of announced withdrawal transients. So the reason we did it this way is we tried to sort of pick some examples of things that, people, even at NANOG here, have sort of basically identified as not good. So the first is, there was an earlier talk by Nick Feimster that basically said, one pattern of spammers announce it as /8, not really hijack, but they announce a /8 and they spam for 10 minutes at a time and then they go away. So as I understand it, these are a very consistent mapping. In other words, we will have seen them before, and while they're away, we will be degrading, their average will be degrading. So when they announce, origins will not react to them favorably. It won't immediately present that data to you. So nominally, if you have suddenly this origin that you don't know what to do with, you'll ask origins, and origins will say, I don't know that one, because it's been squelched. And again, our thought was also that, nominally when there's a large outage, it's possible that a new autonomous system may announce a prefix that was previously announced elsewhere. If we've never seen that mapping before, we'll give it not exactly the benefit of the doubt. We won't immediately say you're all aces with us, but we'll probably present it pretty quickly. So this is not mine. Yeah. Okay. But anyway, so we'll try to present new mappings. And so again, this is entirely submitted for your approval. So again, if people feel by and large that this is a really stupid way to do things, that's perfectly valid feedback. We just tried to make kind of an informed decision, but what we really want is to provide a usable, workable system. So keep that in mind, and comments are totally welcome. Even if you tell me that exact thing again, that's totally cool. But anyway, just to sort of solidify that last point, here's a slide from a previous presentation that essentially shows that announcement withdrawals for these spamming prefixes, are in the order of 10 minutes. And so these sorts of data points are what we tried to use to come up with why we would do this weighted moving average. So now I'll talk about the second type of data that we use in the system, which is user feedback. So what we recognize is that, operational trust, people whose opinions matter, is often gained externally to any kind of automated system. Like here at NANOG, you'll meet people, you'll go to key signing parties, etc. And these are the names that you may trust. And the key signing parties might help you bind the person to some sort of cryptographic entity that you can then verify. And so this is something that we think can basically, I'm going to kind of try and move it along. This is something that basically we think will be very useful when you then want to see if, user so-and-so has really said that this is a mapping, or if it's somebody who's spoofing their name. Go to a key signing party, and then you know. And since we're using a DNS interface, you can use dig. You can basically just dig our database right now. And if you doubt me, go ahead and do it right now. So, this is the UCLA's prefix. And if you literally just run this command, dig, and you sort of reverse the octets and the mask, and you get dig 16.00.179.131 actions bgporigin.org txt record, you'll get back this screen. And what you can basically see in the answer section, I hope, if that's clear, is that there are two records. The first one looks like I vouched for ASN 52. So you parse this by saying prefix, colon, ASN, colon, the key ID that's vouched for it, colon, the name of that person. And the last token is actually the code. So 1 means that I think this is a good mapping. 2 means I think this is a bad mapping. And I can then revoke that signature later. So you'll never see a 3, but 3 will clear this out. And the bottom one with no information is the baseline data. That's what we call from FAS. So the way you submit data is also very simple. So we require that the information you submit is signed by either PGP or GPG. And we chose basically PGP because it's kind of ubiquitous. There are these online key servers that make it very easy for us to get keys and so on and so forth. But also the level of granularity we thought was just right. So there are lots of ways you could sign things, and since we're using DNS, we could have used DNSSEC. But what we really think is that you will care about what somebody you've met thinks. So DNSSEC, the granularity of the keys is not per person necessarily. But PGP is, generally. It can also be organizations, etc. But the idea is that I may show up with a key at the key signing party. You recognize this as me in person, and from now on, when you see my attestation, you know it's me if you care. So we have simple reference scripts that I'll show at the end of the slide where to get, or at the end of the presentation where to get. But for example, this is how you would use the reference script to update or add an attestation. You just simply run the command line with a -A. It'll sort of walk you through what origin do you think that prefix belongs to. Are you trusting it, distrusting? Do you want to revoke something? And then it'll sort of plug into GPG and say, hey, type in your passphrase and sign it, send it off. So basically, the way this whole thing works is GPG and PGP verify individual user signatures. We get these keys from key servers. So basically, you need to have your key somewhere where we can actually get it and other people could actually get it. So we actually pull from the MIT key server. We use DNS to basically make this very easy for people to plug in, write scripts, like I said before, NetDNS or DIG or whatever you want. And similarly, DNS updates work the same way. And our simple reference scripts are basically designed just to sort of like let you play with it, which I hope some of you are doing now. And essentially, you can rewrite this yourself. The scripts should be very easy and well commented so that you can basically, if you have a framework where this would be useful, either use our scripts or write your own to plug in. So basically, in conclusion, I'd like to highlight that BGP Origins, as you may, I hope you've sort of gleaned, is not trying to tell you that its data is the right data. That's kind of something we feel is going to be left to you as the operational community, you as a user. You're basically going to decide what do you think based on the information, but at the same time, we're giving you a venue and a framework so that automatically you can say, it matters to me what this operator has said. And so if this operator happens to have said something about this prefix mapping that I'm seeing, then that's great. That helps me a lot. That basically shifts the onus onto the end user. But nominally, that might be a good thing. Nominally, that might be exactly what allows you to make this system useful, we hope. But it's a non-repudiation framework. No one can say, I never made that attestation. We'll give you the signature, and you can check it yourself. And it's actually online right now. So, nominally, we hope this becomes useful ASAP because it's ready to be used. And again, we'd love to hear feedback. There's a little bit more information at our website, which is on this last slide. And our reference scripts are also linked there, so you can go to that and download the script. It's in Perl, but that's just basically a pragmatic choice. So thank you very much. I wonder if there are any questions.
Yeah, while people are coming to the mics, would Clarence please come up here? Thanks.
It appears you're using the route views historical data, but not the route objects from the IRRs. Is that correct?
That's correct.
And just a request, your slides on the NANOG website seem to be older set. Can you update that, please?
Yeah, I sent them out maybe a little on the late side, but they should be out, and I'll try and make sure that they are properly updated.
Just one more question. How often do you update the database? Like route views, I guess you get every 15 minutes, you get new data. Sorry, go ahead.
We pull a live feed from FAS. As FAS updates, we update, and as I understand it, FAS pulls data from route views as soon as it's available. So essentially, we update as soon as possible.
Thank you.
Majdi Abbas. Not really a question. Since you're using PGP and encouraging people to go to key signings, I figured I'd just mention that the last NANOG key signing session is at the 10:45 break, right through those doors on the left. It is not too late for people to get me their keys.
And now that might actually be something very useful. We hope. We hope to encourage. So again, please feel free to grab me at any point, especially if you think my moving average idea is subpar. We're all ears. We'd love to hear any feedback, and please give the system a shot if you think it's useful.
Excellent. Thank you.